We are from West Godavari Institute of Science and Engineering College. We have done project real-time spear phishing mail detection using AI and ML. Presented by T. Sumitha, Suvarna Kumari, Jnanendra Kumar, and Hemanth Kumar. So, what is phishing mail? Let me know what about the phishing mail. So, phishing mail is a fake email sent by scammers to trick you into a giving personal information like passwords or bank details. It may look like it's from a real company, but it's actually a trap. These emails often ask you to click a link, open an attachment, or enter your details on a fake website. So, why phishing mails are dangerous? Because they can steal your information. Hackers can get your passwords, bank details, and identity information. It may also hack your accounts. If you enter your login details, scammers can take control of your email, social media, or bank accounts. It also spreads viruses. Clicking on the links or downloading attachments can install harmful software on your device. It may cause financial loss. Scammers can use your details to steal money or make unauthorized purchases. To trick you into scams, they may pretend to be a bank or a trusted company to make you send money on a share private. To overcome this model, we developed a model called phishing mail detection. We can overcome this in a traditional way. Existing system traditional phishing detection systems rely on rule based and signature based approaches. These methods includes blacklisted based detection, which means that it maintains a list of non phishing body text and block access to them. However, it fails against newly created phishing sites and heuristic based filters. It uses predefined rules to detect suspicious email patterns but struggles with advanced phishing techniques. And email header analysis. It examines the sender addresses and metadata for anomalies but can be bypassed using sophisticated spoofing techniques. And spam filters. It identifies phishing email by analyzing common spam keywords, but often result in false positives and negatives. In this existing system, we have also some drawbacks, and the drawbacks are limited scalability, high false positives, and inability to detect new phishing tag techniques. While these methods provide some level of protection, they lack adaptability and struggle with the evolving phishing strategies. The need for AI driven intelligent phishing detection is evident to combat sophisticated attacks effectively. So, we have the drawbacks in this existing system. Coming to proposed system leverages identifiable. Coming to proposed system, we use AI, ML, NLP techniques in real time spear phishing. The system follows a multi-layered approach. Input. The system takes incoming email from user in real time. Email include various attributes like sender, subject, body content, attachments, etc. And pre-processing. In this pre-processing, we have text cleaning. Text cleaning includes removing HTML text, special characters, and stopwords from the email content. And feature extraction. It extracts important features from the email such as sender's email address, subject keywords, time of sending, email metadata, body text links, etc. So, phishing detecting model. In this, we use AI and ML algorithm. A machine learning model look like a random forest algorithm, SVM, and deep learning techniques. These are used to classify whether the email is phishing attempt or a legitimate email. This is based on the pre-processed features. So, real-time analysis. In this real-time analysis, the trained model evaluates incoming emails in real time. If the model predicts the email phishing, the system triggers alert or flag the email for further review. Post-processing. In this post-processing, alert generation. If a phishing email is detected, alerts are generated for the user to the IT department. And logging and reporting. The system logs phishing attempts and generates periodic reports for monitoring and system improvement. And next one is user interaction. User can report email that are falsely identified, allowing the system to improve by continuous learning. So, in this proposed system, we have some advantages, and the advantages are high accuracy, adaptability, speed and efficiency, comprehensive analysis, enhanced cybersecurity. So, coming to system requirements, so these are the software requirements and these are the hardware requirements. In software requirements, operating system, Windows family, and version we use Python 3.9.1, and program language is Python, and development idea Jupyter Notebook. And coming to hardware requirement, processor Intel i5, speed 1.1 GHz, and RAM 8 GB RAM, to hard disk 512 GB. To develop this model, we use language Python, and Python is a high level programming language, interactive, and object oriented scripting language. Python is designed to highly readable. It uses the English keywords frequently, whereas other languages use punctuations, and it has fewer syntactical constructions than other languages. And coming to Python features include easy to learn, easy to read, and easy to maintain. So these are the features of Python. And some other features in Python: interactive mode, extendable, database, portable, GUI programming, scalable, and these are the some features in Python. Coming to Python environment, Python is available on a wide variety of platforms, including Linux and Mac OS. So let's understand how to set up our Python environment. Anaconda Navigator. Anaconda Navigator is a desktop graphical user interface included in Anaconda distribution that allows you to launch applications and easily manage Conda packages, environments, and channels without using command line commands. Navigator can search for packages on Anaconda Cloud or any local Anaconda repository. It is available for Windows, Mac OS, and Linux. The following applications are available by default in Jupyter Lab, Jupyter Notebook, Qt Console, Spider, VS Code, Orange 3 App, Rodeo, RS Studio. So these are the default navigators we are used in this model. So, coming to our project, we use Jupyter Notebook for coding. We have we have to install some libraries. So these are the libraries we have to install in our. We have to install these Python libraries: NumPy, Pandas, Keras, TensorFlow, Natural Language Toolkit, Pygame, Seaborn, and these are the Python libraries we have to install in Jupyter Notebook. This is the code: import RE, import NLTK. In NLTK, download stopwords. This is the code for our project. So first, import RE. Import RE means it is a Python built-in module for working with regular expressions, useful for text searching, matching, and cleaning. And next one is import NLTK. NLTK means Natural Language Toolkit. It is a library for working with human language data. And next, NLTK download. Downloads the stopwords and like the is etc. These are the commonly removed in NLP pre-processing. And next, from NLTK, import stopwords list from the NLTK corpus. And Potter stemmer, it reduces words to their stem like running and done. Walnut lemtizer, it converts words to their base or dictionary form. And next, import pandas as DD. It is a powerful data analysis and manipulation library and analyzes it as DD. Next, count vectorization. It converts text into a matrix of token counts. And TF-ID vectorized converts text into a matrix of TF-ID features, which means that capture word importance. And confusion matrix, it evaluates model performance by showing actual versus predicted classification. And accuracy score, it calculates the accuracy of predictions. And learn model specification, it puts a dataset into a training and testing subset. Import pickle, it is used for pickle is used for saving and loading Python objects such as models. And next, import the warning module to manage warning messages. Filter warnings, it suppresses all warning messages. Right. Import the natural language toolkit, a popular library for natural language processing. NLTK downloads. Downloads. NLTK download WordNet. Downloads the WordNet corpus which is needed for lemmatization and imports the WordNet lemmatizer which helps convert words to their root forms using WordNet. Creates an instance of the WordNet lemmatizer which will be used to lemmatize words. Reads a CSV file named spamcollection.csv using Panda and stores it in the variable and specify that the data is tab separated and the column name for the data frame. It encoding ensures the file read with UTF-8 encoding to handle special characters correctly. Returns the shape of the data frame and import pandas is for data manipulation. Matplotlib is for basic plotting. Seaborn is a statistical data visualization library built on top of the Matplotlib. Word cloud is used to generate word clouds from the text data and create a copy of the original data frame DF and stores it in DF1 so any changes won't affect the original. Maps test maps text labels in the label column and ham becomes not spam. Spam becomes spam. This is done to make the labels numerical for analyzing and modeling and create a new figure with a specific size and uses Seaborn to draw a count plot showing how many messages are ham and not spam. And tool one as in a color scheme to the bars. Set the title of the plot and renames the x-axis, tick labels. 0 is shown as ham, 1 is shown as spam. Display the plot. WordNet lemtizer, which reduces words to their base form. And text pre-processing, it analyzes an empty list to store cleaned and pre-processed messages. Loops through allows all messages in the dataset. It uses regex to remove all non-alphabet characters from the messages, converts all characters in the messages to lowercase, splits the message into a list of words, which we can also call as tokens. For each word in the message, lemmatizes the word, removes stop words like the, is, in, which don't add much meaning. Joins the cleaned list of words back into a single string and appends the cleaned message to the train list and prints the number of cleaned messages should be original message count. Initialize count vectorizer which converts text into a numerical feature vectors, limiting up to most frequent words. Fits the vectorization to the cleaned text and transform it into a 2D array. And convert the label colon into one hot encoded format. Displays the displays the first few rows of the encoded labels. Takes the second column, index 1, from the one hot encoded Y data frames, probably the spam column, converts it into a numpy array, resulting in Boolean values. Print the labels and split the data into training and testing sets. X features, Y labels. 80% of training and 20% for testing. And import the multinomial navy base classifier suitable for text classification problems. And it creates a multinomial navy base model object, makes the predictions on the dataset. Next, calculate the confusion matrix which compares predicted versus actual labels, and computes the accuracy of the model percentage of the correct predictions, and displays the accuracy score, which is very good. Again, makes predictions on the test set and prints them, look like a repeat from the above confirmation or reuse. And again, makes the predictions on the test set and print them. Uses the trained navy-based model MB to predict labels, true for spam, false for ham on the test text data. Print show the predicted labels for the test data, and computes the confusion matrix comparing the predicted labels with the actual test labels. Calculates the accuracy of the predictions. Accuracy score equal to correct predictions. Here it gives 98, about 98.48 accuracy, which is very high, and saves the count vectorizer object. Use it for transform messages into word count vectors to file a name transform.tk. Write a binary mode. This allows reusing the same vectorizer later for transforming new input messages on the same way. Saves the train navy-based model MB to a file called nltmodel.tk. You can later load this model and use it to into predict spam ham without retraining. Random forest classifier. It is a ML algorithm. So random forest classifier, a machine learning model that uses an ensembler of decision trees and to evaluate model performances to compute how often predictions match labels. So creates a random forest classifier and trains the random forest model on the training features train X and labels train Y. Predict labels on the test features text X using the trained model. Int output the predicted labels true or false for spam classification. Calculates the confusion matrix for the predictions and actual test labels. And computes the accuracy of the predictions, the proportion of the total correct predictions, which is approximately 98.21 accuracy, slightly lower than the Navi-based model in your earlier. So here we also uses LSTM model and SVM model. So this is our code for our project. Run the code. So it's running, and this is our home page about email spam and email spam detection. Click on the email spam detection and copy the body of the email and predict, and it gives the prediction if it is spam or harm. So yeah, this is our project. Thank you.